Hello, good afternoon. I'm here at Embedded World 2024, and I'm delighted to once again welcome back Jason Kridner and Rob Nelson. So Jason Kridner is the co-founder and president of the board at BeagleBoard.org Foundation. And Rob, you're applications engineer at DigiKey, but I can't do them justice. So Rob, why don't you introduce yourself for us?
Yeah, so I'm Rob. I basically help day-to-day, whether images, kernel release, U-boots, just supporting all the customers, all the users, anyone that wants to build with the boards, just the community aspect of it, just, everything.
Yeah, you've been busy at the show.
Yep, a lot of questions, a lot of answers. Yeah. When can we see the new board?
Yeah, fantastic. Jason, do you want to do a little intro?
Sure. Jason Kridner was involved in founding BeagleBoard.org, and happy to bring on folks like Rob to be a board member and help guide the project in a good direction. We exist as a nonprofit, and we've been around for about 15 years now.
Excellent. So today we're going to chat a little bit about open source and an exciting new product launch. So although we've recently seen rapid growth in sort of computers running open source software, the designs of the computers themselves have typically remained sort of wrapped in mystery and available only to a select few. So what is your primary reasons for adopting open source?
It's for me, open source is somewhat about principles, right? I think that yes, you have sometimes having something that's just your own makes sense, but if it's possible to share it and it doesn't hurt you to share it, I think it's of great benefit to the world for you to share it and give it back, right? And so at BeagleBoard, all the hardware designs that we do, we give away as open source. And that's more like what the early days of computers were, when people way back when got a computer. They didn't just get the computer, they got the information about how the computer was built and the software, the source of the software that was running on the computer, so they could figure out what to do with it. Yeah. And I think as these computers become more and more complicated and there's more and more things that they can do, it's even more important today that when you get your computer, that you get the design files for the hardware and the software, so that you can dive and really understand what's going on inside your system.
Yeah, definitely.
And like Jason, I kind of go the same angle. I look at it as maintainability.
Right.
I have this product, it works today. I want to be able to use it again tomorrow. I want to know how it works. I want to know how to fix it. I just don't want to throw it in the garbage and be done with it. That is not so good for the world.
Yeah. But exactly. So there must be some sort of environmental and economic benefits to adopting open source as well. We all know that there's a big problem with, waste in electronics. So that must be a massive environmental factor as well.
And if you can't find out how it was made, you can't fix it, right? And for young people trying to learn about how these things are put together and built, right, it gives them so much more ability to dive deep into their knowledge. Yeah.
So how does sort of the open source technology benefit hobbyists, educators, as well as professional engineers?
I think the big thing is on the education standpoint. It gives something that you're teaching the new group how things work, every little detail. You're just not giving this blob and say, you just run this. They every little detail on it, and then they go to the industry and they know of the principles of it, and they teach it to their coworkers.
Yeah, fantastic.
From a professional point of view, right, being able to go and solve problems and at a very detailed level, if something's coming up maybe right away or down the line, to be able to get into the details and work to actually solve those problems and maybe share the solution with other people so that other people can benefit from it, but certainly so that you can benefit from it yourself. Yep. And to be able to take control of things and actually make that fix, apply that fix, buy the right parts, and actually produce a solution that continues to solve your problems.
Yeah. So what challenges do manufacturers face then when trying to integrate sort of open source into their electronics?
End of life, part shortages. We all remember the last 2 years.
No.
There's challenges every new day. And a lot of them is just, okay, these parts end of life, let's flip to something else. And that's part of our job with the open source too, is, okay, we got to swap things. We've got to make sure it works. So we help patch it and make,
Yeah.
I do notice some confusion sometimes when people say that we're open source, and they think that if they do something, they have to give away their schematics. And I mean, it's nice, but there's absolutely no need, right?
Yeah, there's no license on our designs. Basically, they can do what they want, just don't put the logo on it.
Excellent. Yeah. Well, I mean, that was my next question. Tell us more about sort of the philosophy of BeagleBoard's open source,
Yeah, so we license our schematics under Creative Commons, and you can go and make the boards yourself, but the only thing that's restricted, right, is our logo, right? So that's a licensed element on the board, right? If you want to make a board and say that it's BeagleBoard.org, well, that's not nice, right? If you buy something that says BeagleBoard.org, you want to know that BeagleBoard is responsible for the manufacture and production and the quality and support of that product. But other than that, there's no real restrictions on what people can do with the design materials.
And we see that as key too. It's like our schematics well tested, the TPSs work, the DDR works, all the traces work. So you can take the core of our design and just build your own product around it.
Yeah.
That core is well tested.
Yeah.
Like on the AM3G, what is it, 12 years of testing at this point? 13 years?
Hundreds of thousands of projects and applications where people have used things in different scenarios.
And that design's been in space.
Many times.
Amazing.
Yep.
Yeah.
So well tested.
Entire satellite networks, actually. So
That's why
Brilliant.
it was kind of scary about it. A year ago, we had to redesign part of it because of one end-of-life change. So it's like we had to change the PCB for the first time, 10 years? Just for the micro SD cage went out of life.
Yeah. And we continue to, as parts do go end of life, right, to update design, right? So I mean, that's part of BeagleBoard's commitment to longevity.
Yeah.
And we open source those updates.
Yeah, fantastic. So, I'd like to talk about something new and exciting, which is the BeagleY-AI, the latest and arguably one of the most impactful in a long history of innovative open source single board computers. So, tell us about it. What are the specifications? What's exciting about it? Why should we be as excited as you two very clearly are?
Well, it's a brand new processor, and it was kind of cool for us at Beagle. TI came and was like, we want to do a processor with you. And the way things lined up, we actually announced their processor before they did. So it uses TI's AM67A. I think what's the code name? J722S is the internal family.
Yeah, but it's a vision processor.
It's a vision processor. So it's a quad-core A53. We have, was it 4 tops, 8 tops?
Four tops.
4 tops.
And on C7 DSPs that you can be reprogrammed. And
there's 3 R5s on it, so 2 of them will be general purpose. So one is for boot up, and we think we can make it general purpose. But
so there's a lot of specialized compute capability that takes beyond what you'd have in other systems. That compute capability is really important for embedded systems.
Yeah.
But the first thing that I think of when I see BeagleY-AI is the fact that it's in a different form factor than the other Beagles. It's in a very, I'd say, industry standard.
very common standard.
Very common form factor.
And because of PCI, we decided to put a certain PCI connector on it. So hopefully we can see some cool designs with that.
Excellent. Yeah.
So it already works with a ton of enclosures and add-on boards. It's got a 40-pin header on there where you can attach hats to it. And we find it really, really easy to take a project that might have been used with another single-board computer, swap it out, use the same ARM Linux software that's already running on another platform, and just add our bootloader and kernel to it. And then we can start doing all the special things that BeagleY-AI and the TI AM67A can do.
Yeah.
And I'm really going to say we're going to thank our partners on this one big time, because behind the scenes, if you know how fast we did this, it was crazy.
Go on, tell us.
We started this in November?
It was right around Thanksgiving, around someone else's launch.
Say no more. So how does the BeagleY-AI fit in with the open source philosophy that we've been speaking about?
So actually, the kernel patch was just submitted last week, and I have to do a couple changes. So I was talking about open source. We should be able to hit the next RC. Please, Nishan. But yeah, there's one change I have to make. I'll resubmit. U-boot should follow pretty soon. So yeah.
Yeah.
So as people are getting boards, they'll be able to probably boot mainline Linux kernels and run that on them. But the hardware itself is open source. And I think it's interesting to kind of feed into an ecosystem that's there's already a lot of popular usage, but now you've got an open hardware reference design that you can use to kind of start from that footprint and evolve and move it forward, right? So we've tried to stay very true to the examples, right, that we're given, right? So it's got the ribbon cable PCI Express. We did make a change. We went from having just 2 USB 3s and 2 USB 2s to having just made all 4 USB 3s.
Okay.
And we swapped one of the micro HDMIs for a OLDI ribbon cable, so you can put really low-cost touch panels on it.
Fantastic.
And as far as mainline on that too, TI's been pushing it the last couple weeks because it's officially launched now. So out of the box, yeah, we should see a lot of designs based on the AM67A, so it'll be very exciting. It's very low power and very kind of cool running.
Yeah.
We were kind of surprised at that, so.
I'm pretty proud of the price point we came in at as well, right?
I think, yeah, a lot of our customers will appreciate the price point.
Yeah. So what is the price point?
It's around $70 for a 4 gigabyte model.
Fantastic. So how can individuals and organizations contribute to your community and help participate, and help grow this open source sort of innovation that we've been talking about?
I'd say there's a couple ways to interact with us directly. The biggest one that we've kind of moved to in the last year has been Discord. So we have a Discord channel.
Oh, okay.
I think it's 1,200 people on it. So we have TI developers on there too. We have community people, and we have a lot of discussion, especially around GSOC that time of year. We have our own GitLab instance that Jason put up. We have our own CI builders at openbeagle.org. If you sign up, ping us if you want CI, because then we can enable it. We got ARM64, we got ARM32, we have RISC-64 builders, we have x86, and we're trying to add more as we need them. But basically, we're giving you whatever you need to help build projects.
Yep. So we provide a lot of build infrastructure. There's access to issue trackers. They can submit bug fixes. They can get involved in things that are going into our Debian package repos. So Robert is just an absolute monster at that. So they can get engaged on those types of projects.
And then, of course, the forums.
And the forums.
Forum will always be there, but
yeah.
And that's kind of the best way to follow up. But I would also encourage people to participate in the upstream projects, right? Yeah. Participate in Buildroot and Yocto, different application environments like the Home Assistant or any other kind of distro application level things, and add support for BeagleY-AI, I think, and then come to the forums and let us know that it's there.
Yeah, definitely.
And our goal is just to help them run whatever mainline code they want. So it's like, you can ask us for help in who you want to talk to, but just submit to other mainline organizations like Mesa, like Kernel, U-Boot, and we'll just help you.
Yeah. So what are the future goals of the BeagleBoard Foundation, in terms of advancing open source? Are you allowed to tell us any secret plans that you've got?
We try to take a lot of feedback from the community about what types of things we're doing, right? We're continuing to do boards around the Pocket Beagle and BeagleBone form factors, right? Yeah.
So the form factor's not going away.
It's not going away. We're still doing stuff. We're still doing stuff with peer use. I know that's a big interest for people. For the BeagleY-AI, instead of having peer use for IOs, we're using R5s. For IOs, but for the Pocket Beagle and the BeagleBone Black form factors, we'll continue to do peer use to kind of leverage of that existing infrastructure, but more modernizing it, right? So I think continuing to serve whatever our community's needs are.
And of course, from GSOC and education aspect of it too, and helping people get involved.
I think now we want to just really, it's full headed into documentation and demos, right? Telling people how to go do fun, cool things.
Yeah.
And as we've been playing with this board for the last month or so, we've been really happy with how easy it is for us, and hope that we can translate that into make it really easy for other people to solve their problems.
Yeah. Okay. And before we wrap up then, what is what feature on the board makes you the most excited?
For the BeagleY-AI, I think it's the form factor, right? I think that some of the compute capability with the R5s and the DSPs and stuff is really cool. But just being able to plop it into things that it already exists within that form factor is the most exciting for me.
And I think, from my standpoint, just seeing all the R5s, we've had a ton of community questions on that already. The boards aren't out, but just utilizing all those R5s together. I mean, we have a quad-core A53 for Linux, but we have all these cool processors with tight timings and...
Yeah, well, I'm excited to see all the cool applications that are going to come out. We'll chat about that next year at Embedded World.
Perfect.
Brilliant. Thank you both.